Hello, welcome to simulation, a learning simulation. This time we will talk about how to simulate with variables. Variable is something that is capable of changing or varying, and variables are placeholders for real numbers or integer numbers. And these are very useful because you can use them during the simulation. So variables are typically used for making decisions or for gathering data, but more important is to track the statistics, and you also may monitor other activities during the simulation run. This is very practical because you want to know when you build a model whether your model is working the way it's supposed to. So whenever you don't have entities coming to a location and you don't see any activity, that means that something is wrong. So it may also use to troubleshoot and also to validate your model. The variables, the typical variables that you can use is to track your customers waiting in multiple queues, customer waiting time during a specific time period, or entities that come into a store or a manufacturing area, bank or office. Sometimes you want to track the WIP, the work in process inventory, and sometimes you want to track also the production quantity. Not only than that, but you can track production time, a specific elapsed time or lead time that it takes to make a product or a certain type of inventory. So these are the typical variables, production time and inventory, that in manufacturing or service systems are critical. And in our Pro model menu is this X as the symbol for a variable. So that's something new that is coming at your learning. There's different types of variables. There are the global variables and the local variables. Later on, we'll talk about the local variables, but in this case, we will start with the global. So the global means is global within the simulation model. Any part of the model, any location, you can start tracking any of the variables that we just mentioned. So, and you can access those anywhere in your process map. So the value of the global may be displayed dynamically during the simulation. Like I said, let's say that I want to trace production. This actual number keeps coming as your simulation run. You start to see how many entities are coming into the final end before they exit. So if you want to dynamically trace the total production, this is a great example. So you click here variables, you create a total production, create an icon and put the icon in the layout. Okay. This is the first step. Later on you need to add these variable into the processing routing to see at what point you want to trace this production. So in an essence, that's what it is. So let's go and ahead and see how we can do this. Okay, so as an example, we're going to take the Southern California Forgings with a monitor the working process inventory, the WIP, and also the total production. Later on, we'll talk about the increment and decrement variables statements. So in the Southern California Forgings, there's a machine shop that has these castings, and they have batches of 5 raw forgings that arrive on an average of every hour, exponentially distributed. And the raw material, they're sent to the mill process with a processing time of 10 minutes and standard depth of 1 minute, normal distributed. And these mill forgings, they go to a grinding process, and it takes about 6 to 10 minutes. So it's a uniform distribution. After the grinding process, they go to a finished part store. So it's pretty easy. It's just a 2-step process. And then we're going to model this machine shop for 6 months. We will track during the simulation the work in process inventory and the amount of production during the 6 months. So since a long simulation, it's good to have these variables so we can monitor the amount of production. We also assume that it takes 1 minute to move the parts between locations. So the key questions is to find out the average and maximum amount of inventory. These always companies are dealing with cash flow issues, so monitoring is one of the key performance indicators. And also, what is the week of maximum WIP inventory? So then you can go back to your supply chain folks, all the planning department, and say, hey, what happened in this maximum work in process inventory? Or you can also talk to the production manager, say what happened, how come we accumulate so much inventory in this WIP location. And last, to find and monitor the total production, remember the variables are also helpful to see if your model is working, and it helps in the troubleshooting part. So now let's go and let's get to it. Let's go to the simulation. Okay, now that we have created our locations, remember when we receive items, they're usually infinite location and finished parts as well. They go into infinite. So now let's keep track of our entities, and we know that entities are usually the forgings that we talk about, the arrivals that we're receiving a quantity of 5. So these are batches of 5 that occur every hour, every 60 minutes. You can actually put 1 hour or make it 60 minutes. Let's go now to the processing to get familiarized with the processing. So they come to the receiving area and then go to the milling process, then the grinder, and then the finished parts. As you can see, the milling is a normal distribution and the grinder is uniform distribution. Just remember to put your move for, in this case, we're not using any resources. We're just assuming that the entity it takes to move for 1 minute. You can see the move logic. So now that we have built our processing, remember our LIP, location, entities, arrivals, and processing. In this case, we're not going to use any resources at the moment. So now we can go straight to the variables. So these variables are the placeholders that change during the simulation. And then we said that we need to create the first variable. It was WIP, work in process inventory. And you can see there's no icons because WIP is just a counter. So ProModel automatically has a counter icon. So I'm going to put my mouse here, and I don't need that many digits, so I'm going to change the font to a different number. So let's say, so I can see it better, I'm going to put a 20. Yeah, that's much better. So this case, I don't need to do that many count, but if you're dealing with so many parts, then you can change the icon to see more digits. So automatically when I click, it creates the icon, is the counter, and is integer value. I have actually real or integer. Those are the ones that I have. When you use real numbers is when you have fractions, but in case these are whole numbers, so it's an integer value, and the initial value is 0. So that means that when it comes to WIP, these counters start to track. So initial value assumes that there's nothing in there. So initial value is 0. You may change the initial value. Let's say if you're doing this analysis when the company already has, let's say 500 parts in inventory, then you can change this initial value to 500. Right? And these are the statistics that is going to go through. Is going to go through a time series. So later on we will find out how to track that WIP in the report of ProModel. The next one that we're going to track is the production or total production. Just for the sake, I'm just going to put production here. Okay. So those are going to be my two trackers. One is the WIP, meaning the amount of work in process inventory before entities exit the production system. And then at the end, I'm going to track my production. You can even change the color. I'm going to change the color to a different, so I don't confuse when I'm tracking my production versus my WIP, and I will know that the yellow is going to be production. So coloring can be a different distinction. I can also later show you how to put the titles here later on, but let's just stick to it. I think graphically we will know that everything in between is WIP, and at the end is our finished parts counter of total production. So now that we create these variables, they need to interact in our processing, right? Remember that we already created a processing map, and now we need to find out where we're going to use these variables. So if you want to keep track of inventory, you can go to the operation, right? And then type the variable. In this case is the WIP. As you can type the WIP variable that you created, automatically ProModel shows you a green V on the left. This means that this is a variable. Okay. Wait until is actually a command within ProModel. So if I choose wait until, nothing comes on the left. But in this case, WIP is telling you that this is a variable within the simulation. So I'm going to put WIP equals WIP. Now, if I just want to track WIP equals WIP, I pretty much won't track anything because the initial value was 0. So I need to pretty much increment this production as entity comes to the receiving area. This will take the initial value of 0 and then increment it by 1. Okay. So let's see how it works in the simulator. So you can see start to track the amount of inventory that comes in here. But in this case, I don't think that I have that much inventory, right? Because all I'm doing is just to increment the amount of parts that are coming to the system in my receiving area. But this is not what I want to do. So let's stop the simulation. I don't want to collect any statistics. I'm just doing this so that you know what is the logic. But what I want to do is that I know that this is working. My counter is working, is counting the number of parts, remember, every 5. So now what I want to do is in the finished parts, when they exit, I want to use the WIP equals the variable that we created, which is -1. So meaning that anything that is in between, anytime that entity is finished and is forged already, is no longer in my WIP inventory. So I'm going to have to subtract it. So now let's see how it looks in our simulation. Now that, okay, so 5 enters and their exit, they is now to get subtracted, right? As you can see, this is not longer incrementing in batches of 5. So this is the beauty that now I know that my counter is working. I'm just going to accelerate my clock, and you can see the variation of amount of inventory that is in my process during my simulation run. Okay. So yes, so now this is a proof that now you can track the amount of WIP that is in the system. Okay. So let me just stop it here. So now work on the next assignment, which is to monitor the actual production, right? I don't have to wait until 6 months and see what was my result of total production. So I'm going to go back to my variables and look at the production. That's the variable name. So if I see this wording production, it's going to turn into a variable. So I expect to see a green symbol when I'm going to my processing. So, and again, I don't need to track it production at the beginning because there's actually no production. This is actually just showing the amount of parts that are coming in, but I'm going to be interested in what comes out after the finished parts. So there's a second line here. This is a programming line to enter your syntax. So in this case, I'm going to put the word production, and look at what happened. I start to put the P. There's all these are commands that I can use for per model, pause model. I can use a pause model. But production, when I type the P production, is a variable. So it already knows that this is a variable equals production. Again, it shows here a variable. Okay. And then all I can say, the initial value of production at the beginning was 0. So I need to just add a 1 so it can increment the amount of production. Every time that entity comes out of the finished parts will be counted. So the initial value is obvious 0. I won't be able to track anything until I put the 1. So let's see if my counter for production is working. All right, so now I have my total production count, right? I'm just going to accelerate this. And you can see the amount of production, the amount of WIP, right, that comes in. This is to monitor. I'm going to uncheck the animation so it can run through all the number of hours, which is around 6 months of production, and over 1,000 hours, something like that. And let's see. And then when we 1,040 hours. So now let's see the results. So this is a good way to track your information. Okay, so now we have here the results. Looks like there was 4131 exits. Time in the system 321. But I'm more interested with the amount of inventory WIP, and to see if the things that I see is what is the average and maximum amount of WIP inventory. I already see that there's sort of a blockage. So it says that there's a lot of non-value added in the system, that's our job, to see how we can smooth flow in our improvement phase. But let's see now, there's a new, since we created variables, ProModel creates now the analytics for you, the variables that you want to see. So I'm going to select here the variables that we selected with total amount of, and the maximum. This is now the answer of my questions. What is the average value inventory and the maximum? So looks like the average was about 26, and then the maximum value was 127. So again, these are the two things that I want to know. And also my production, my production was 5,000. So a work in process inventory. So for that, I'm going to use, this is a time series, right? I want to use a plot. So the plot is a time series because I want to see over time. And obviously this is the receiving area. I'm not interested in the receiving area. So I'm going to just click my filter, uncheck the receiving area, and click on my WIP, right? I also can change the intervals, right? by the, let's say, hourly. Okay, I want to see hourly because sometimes maybe in the beginning of the shift, second shift, or third shift, but you can even change the intervals of tracking. So now, guess what, guys? I found out that my peak was here. So yes, it's around 127, and you can actually click here and looks like 3.77. It's 6 weeks, right? But this is just the simulation clock. So I'm going to show you now the way to get these analytics and do the translation. In three. All right, now that we found out the maximum amount of inventory, let's now convert our number of weeks in the simulation run into actual working weeks. So we have our number of 3.78 weeks in the simulation run. So now we need to translate that in number of hours, 7 days a week times 24. So we have about 635 runtime. And remember, each week in is about 40 hours of working week, so it's about one shift. And if we divide that, we find out how many weeks of work we actually found the maximum inventory. As you can see in this line, this will be a good conversation to have. This is where you can go back and have a discussion with planning or manufacturing to see this is the area, all these weeks where we have the maximum amount of inventory, and what are the strategies that we can use to minimize that to improve the flow rate. Okay, folks, so thank you very much for watching, and we'll see you in the next model.